Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to continue in our book of marine systems. And yes, this is the chapter 2, hydraulic systems, and we are going to continue with the second episode. In this episode we are going to discover what is the physical law for the hydraulic systems. Why those hydraulic systems multiply the force and the torque dramatically. Yes, this is basically because the hydraulic circuits follow the rules, the laws of Mr. Pascal. And what is the formula for the pressure according with the Pascal law? The pressure should be equal to the force divided by the area. This is the secret. But the secret is not only the formula. The secret is what happened in a hydraulic circuit completely closed. What happened in a hydraulic circuit hermetic? Yes, the pressure is constant in all the points. Exactly. For that reason, in the brake system in your car, when you apply the brake pedal, that force that you apply in the brake pedal is transmitted in all the system and finally in the pads on the discs. It's because the pressure is constant. The pressure is constant, not the force. Because if you check the formula, pressure is equal force divided by area. Oh, the force change depending of the area of the pipes. And right now we are going to analyze that situation, especially in actuators, in cylinders. Okay, but the secret, once again, in those hydraulic circuits is the fluid. Let me check the last sentence of this slide. The power that is applied at one point is transmitted to another point using an incompressible fluid. Remember, in the previous episode, we explained the difference in between compressible fluids and uncompressible fluids. The uncompressible fluids are fluids that are practically impossible to compress. The hydraulic fluid is considered uncompressible fluid, but it's not a perfect uncompressible fluid. The brake fluid is a perfect incompressible fluid because it's impossible to reduce the volume of the brake fluid a little. It's practically impossible. Alright, for that reason, with the brake fluid, you can transmit the force exactly the same in all the points. And we are going to analyze later in the next episode the quality of the fluids used in hydraulic systems and the additives, the components of those additive fluids. Those additive fluids are different depending of the application. Yeah, the people know the most common hydraulic fluid is the automatic transmission fluid, the ATF. You remember that, the red one. This is the most common. I love it, that fluid, because that fluid I consider is universal. You can use that fluid in different type of hydraulic system. But once again, follow the manufacturer recommendation. Follow the instruction of the manufacturer according with the fluid. Okay, my friends. And don't forget, in the previous episode, we explained the main difference in between hydraulic and pneumatic. In hydraulic systems, the fluid is liquid. In pneumatic systems, the fluid is air. Yeah, and that's the main difference. In general terms, the hydraulic systems are used to transmit too much power, and but at a slow speed. Yeah. For example, if you have an actuator and you have an hydraulic actuator, those hydraulic actuators, the movement of the piston, like this one that we have on the screen right now, is too slow in comparison with the pneumatic actuators. The response of pneumatic actuators is a fast response because this is the consequence of the fluid. Yeah, pneumatics is used for high speed but low torque, low output torque. Okay, my friends, right now we are going to start to study in details the Pascal law. To study the Pascal law, normally I use a perfect example that is the hydraulic jack. It's the jack that you have in your car. the bottle that you have in the hydraulic jack. This is a perfect example because with your hands you apply a small force. However, you lift your car of 3 tons, 5 tons, depending of the bottle. But this is the hydraulic jack, and we are going to analyze in the next example the hydraulic jack and how because the pressure is constant in the system, how the force change depending of the area of the piston. This is the most important part, and we are going to analyze depending of the diameter of the piston, the distance that each piston travels. Yes, this is a perfect example. Suppose that you have a closed container like this with 2 cylinders. In the left side of your screen is the cylinder with a small diameter. In the right side you have the cylinder with a bigger diameter. In the left side we have a cylinder with a piston. The area of the piston is 1 square inch, and the area of the piston number 2, the bigger piston, is 10 square inches. Okay, and the fluid internally in that container is a hydraulic fluid, and of course the pressure is constant. What is the meaning of that? The pressure number 1 should be equal to the pressure number 2. That's the starting point. We are going to start with that concept. Pressure number 1 should be equal to pressure number 2. Okay, according with the Pascal law, what is the definition for a pressure? Pressure is equal to the force divided by the area. This is in the position number 1, and in the position number 2 should be equal to the force divided by the area number 2. Alright, suppose that we are going to apply in the piston number 1 a small force. We are going to apply 1 pound, 1 pound of force, 1 pound of force in the piston number 1, and we are going to calculate how much is the force at the second point. This is the $1 million question. We are going to calculate how much is that force if I apply a pound in the small cylinder and with an area of 1 square inch. How much is the output force in the second cylinder with an area of 10 square inches, because the area of the second piston is 10 square inch. Okay, we are going to use the formula, the simple formula of the Pascal law. The pressure is equal to force divided by area, and because the pressure is constant, the situation in the position 1 should be equal to the situation in the position 2. In that case, force 1 divided by area 1 should be equal to force 2 divided by area 2. How much is the force number 1? The force number 1 is 1 pound. How much is the area number 1? Is 1 square inch. 1 square inch. Okay, in the second side, how much is the force number 2? This is the $1 million question, no? That's the question. And it's divided for the area is 10 square inches. 10 square inches. Okay, right now it's too simple because the force number 2 should be equal to 1 pound times 10 square inches divided by 1 square inch. Okay, square inches with square inches bye, and the force number 2 is equal to 10 pounds. Wow, 10 pounds. I multiply 10 times in this particular example because the diameter, because the area of the piston increased 10 times. It's a lot, no? It's a lot. This is a lot. This is the force, the final force in the second piston. 10 pounds. You only apply 1 pound in one side, and in the other side you have 10 pounds in this particular example. All of this is possible basically because the fluid is a hydraulic fluid, and because the system is completely hermetic, is completely closed. Once again, we are going to refresh in our previous episode hydraulic system that you have in your boat and in your car. Okay, we mentioned the brake system is a complete hermetic closed system. Give me an example of other system that is completely closed. Hydraulic system. Remember, There are a lot of hydraulic systems. Yes, the coolant system. The coolant is supposed that is hermetic, is closed. You remember in our previous courses of gasoline and diesel, I explained in details the coolant system. And I mentioned several times that you never need recover the amount of coolant in your car, only if you have a leak. In the moment that you have a leak, right now the internal pressure of the system is not the same, it's not constant, because you have a leak, you have a small hole. In that moment the system is not hermetic, it's not closed. Other perfect example of a completely hermetic, completely closed hydraulic system. Yes, in the air condition, the refrigerant, the freon in the air condition is moving in a perfect closed system. How many times you need to recover the freon in the air condition in your home? Never. In the air condition of your car? Never. Only if it's broken and you have a leak of refrigerant. Yeah? Those are examples of hermetic closed system. In those systems, in those hermetic closed systems, the pressure is constant in all the points of the system. Yeah? Give me examples of hydraulic systems that is not fully closed, it's not hermetic, it's partially closed. Yes, the fresh water system in your boat. Oh yes, when you open the shower, the faucet for the shower, immediately the pressure in the system reduces because water is coming out in that point. And immediately you hear the fresh water pump start again to pressurize the system again. Yes, my friend, the fresh water system is a semi-closed system. It's not fully closed. Yes. Other system that is partially closed is not completely hermetic. Other hydraulic system. Yes, the motor oil. The oil in your engine. You remember the pressure on the oil pressure gauge? Depend of the film of oil in between the bearings and the crankshaft. You remember that? Alright, but what happened when the oil reached the top? You remember on the rocker arms and lubricate the rocker arms? In that moment, the oil is at atmospheric pressure and goes down by gravity. You remember that video? Exactly. That system is not completely closed. It's partially closed. Alright, my friends, when we mention hydraulic systems like the bow thrusters, like the actuator for the garage door, those systems are completely closed, hermetic. In those systems, the pressure should be constant, unless you have a leak. In that moment, if you have a leak, the pressure is not constant because you have a drain, and air enter in the system. And once again, in this system, the enemy is the air and the water, the humidity. Yeah. But we are going to study later what happens if the oil is foaming with bubbles of air. Okay, we are going to continue. Right now, we calculate the output force, and yes, we demonstrate that the hydraulic system multiply too much the output force, depending of the diameter of the pipes and the pistons. Yeah, this is critical for that reason. In the next episode, we are going to talk about the cylinders, the actuators, and yes, we are going to investigate what happened internally in the cylinders. We are going to study the different type of cylinders, and we are going to verify what happened if the cylinder is a single pore, double shaft, single shaft, double, the different options. Yes. And in each particular hydraulic system in your boat, we are going to analyze the actuator for that system. The actuator for the twin taps, the actuator for the passarella, the actuator, yeah. For different situations, the actuators are completely different, the cylinders. Alright, this is the output force. But what happened with the movement of the pistons in this particular example? Okay, in this particular example, we say that we are going to apply a force of 1 pound in the position number 1. And we are going to move the piston number 1 10 inches down. Yeah, we are going to move that piston 10 inches down. And we are going to calculate how much is moving the second the second cylinder up. Yes, we are going to apply in the first position 1 pound, and we are going to move down the cylinder number 1 10 inches. And now we are going to calculate what happened in the second position. Yes, we calculate previously that the output force is 10 pounds. And now we are going to calculate how much distance is moved the second cylinder. Okay, to calculate the output force, we use one concept that stays constant, is the pressure. But there is another concept that stays constant, similar to the pressure. Yes, the work. If the pressure is constant internally, the work is constant. You remember what is the formula to calculate the work, my friends? What is the formula to calculate the work? Work is equal to the force times the distance. Okay, because we are going to use the same scenario, the same piston, the same cylinder, the same situation, and we are going to apply 1 pound here, and the final force in the output side is 10 pounds, and this area is 10 square inches, and the first area is 1 square inch. Yeah, no problem. The situation is the same. But right now, we are going to use the concept of work to calculate if the piston number 1 move in this distance, 10 inches, how much is the movement of the piston, how much is the distance that the piston number 2 is moving up. Okay, the work in the position number 1 should be equal to the work in the position number 2. What is the formula for the work? It's the force number 1 times the distance number 1. And what about the situation in the second position? Is the force number 2 times the distance number 2. Alright, how much is the force number 1? The force number 1, by definition, is 1 pound. And how much is the distance number 1? Is 10 inches, no? 10 inches. And what about the second position? How much is the force number 2? We calculate previously, is 10 pounds. Is 10 pounds. And how much is the distance number 2? This is the $1 million question in this particular example. Okay, the distance number 2, this is 1 pound times 10 inches and divided by 10 pounds. Okay, pounds with pounds, bye-bye, and 10 with 10, bye-bye, and the distance number 2 is 1 inch. The second piston only moves 1 inch. And the first piston is moving down 10 inches. Yes, for that reason, in the hydraulic jack, in your car, you move all of this, and the piston only moves up 1 inch. But with a lot of force over there. Here you need a small force, and the final result in the other side is high force, but a small distance. This is the hydraulic jack. This is the situation. We are going to refresh. In order to calculate the output force, we are going to use the concept of the constant pressure. In order to calculate the output distance, we are going to use the concept of constant work. If you have clear those concepts, you can calculate in the future the distance of the ram, the pressure in the output, in order to calculate the torque. This is very, very important, my friends. In the chapter dedicated to the power steering system, the output force produced on the rod of the ram is critical in order to calculate how much torque I am going to create on the rudder. Because in some boats with a big rudder, like the sailboat, is critical the torque applied on the shaft. Yeah, you enjoy this explanation, and of course in your book you found it exactly the same explanation with the same example. You see, it's the force number 1 with the area number 1 is 1 inch, and we are going to use the same concept about the pressure. The pressure number 1 should be equal to the pressure number. It's exactly the same explanation that I did right now in this video. You found that explanation properly explained step by step. All right, this is the second part is using the work, the concept of work, in order to calculate the distance. And finally, the distance number 2 is 1 inch. Exactly the same example with the same numbers. Yeah, if you have questions, you can check in your book carefully that explanation. All right, my friends. Now it's clear the Pascal law, and this is the law that states the behavior of the fluid in hydraulic system. Exactly the same that we study in electricity. You remember with the Ohm law. The Ohm law, voltage equal intensity times resistance. With that formula, we calculate everything, and pressure. You remember, pressure equal voltage times intensity. It's exactly the same here with hydraulic system, because the electrical system and the hydraulic systems, they are parallels. They have a similar diagrams, similar calculation. All right, my friends, and now I have a couple of examples in order to apply the concept of the Pascal law. This is a perfect example. A hydraulic press. This is another good example of a closed system similar to the hydraulic jack. The hydraulic press has an input cylinder of 1 inch in diameter, no area, diameter. And the output cylinder have 6 inches in diameter. Suppose that the efficiency of the system is 100%, is an ideal situation. And we are going to try to find the force in the output piston, the force number 2, if you apply 10 pounds of force in the piston number 1. This is a typical example to apply the Pascal law. And after that, the second part of the question is about the distance. The question said, if the input piston is moving 4 inches, how much should be moving the output piston, the piston number 2? Yeah, we are going to do both calculations. It's too simple. We are going to check the situation in both sides, in piston number 1 and piston number 2. In piston number 1, the diameter is 1 inch, diameter, no area, my friends. If you have the diameter, how much is the area? The area is equal to pi times the diameter squared divided by 4. Okay, in this particular case, is pi 3.1416 times the diameter square is 1 and divided by 4. And yes, we are going to calculate quickly. Is 3.1416 divided by 4 is 0.78. 0.78 square inches. This is the area number 1. And the force number 1, according with the question, is 10 pounds. Okay, the situation in piston number 2, they say that the diameter is 6 inches, and how much is the area? Is pi times the diameter squared divided by 4. Okay, it's 36 times 3.1416 and divided by 4 should be 28.27. And how much is the force number 1? Okay, we are going to use the Pascal law. Pressure number 1 should be equal to pressure number 2. The pressure number 1 is the force number 1 divided by the area number 1, and the pressure number 2 is the force number 2 divided by the area number 2. How much is the force number 1? 10 pounds. 10 pounds divided by the area 1 is 0.78 square inches, and this is equal to the force number 1, $1 million question. $1 million question divided by the area is 28.27. Okay, the force number 2 is equal times 10 and divided by 0.78 is 362 pounds. We are going to return, yeah, it's probably for the decimals, but exactly, this is the procedure. This is the procedure to calculate the force. And now, using the concept of a work, we are going to calculate the distance that is moving the second piston. Okay, in that case we are going to use the concept of work. The work number 1 should be equal to the work number 2. The work number 1 is the force 1 times the distance 1 should be equal to the force number 2 times the distance number 2. How much is the force number 1? The force number 1 is 10 pounds, and okay, it's 10 pounds. And how much is the distance number 1? The distance number 1, according with the question, is the distance number 1 is 4 inches. Is 4 inches, and okay, and the question is the $1 million question is this one, and the output force is 360 pounds. Okay, the distance number 2 is equal to 10 pounds times 4 inches divided by 360 is 40 divided by 360 is 0.11. Okay, and this is the distance that the piston number 2 is moving. Yeah, it's a simple example. We have another great example. A car with a total weight of 2,500 pounds is at rest over 4 tires. The area of contact of each tire is 14 square inches. What is the pressure? What is the pressure that the ground experience beneath the tires because the car, right? And this is one excellent example about the Pascal law. Okay, if the car, the total weight is 2,500 pounds. And of course the car released on 4 tires. How much is the force in one tire? The force in one tire is equal to 2,500 divided by 4. It's 2,500 divided by 4 is 625 pounds. Okay, and how much is the pressure? The pressure is the force divided by the area is 625 divided by 14 divided by 14. This is 44 psi. 44 psi. This is another great example about the Pascal law. Thank you.